properties today, and we're going to be focusing mostly today on multiplying situations with exponents. So first, a couple of rules. Okay, here's the first rule. X to the m times x to the n equals x to the m plus n. Now what this means, for example, is if I just have x to the third times x to the fifth, I just add these two exponents and I get x to the eighth. All right? Sometimes they write it differently. Like we'll call this example 1. They could also say something like x times x to the sixth. Well, this means the same thing as number 1. It's just packaged a little bit differently. This is x to the first times x to the sixth. If there's no power, then the power is 1. So we add these two exponents and we get x to the seventh. Now, what if I had this problem? X to the fifth times y to the seventh. Well, to be able to use this rule up here, the bases have to be the same. These bases are not the same, so there is no change in this one. This stays as x to the fifth, y to the seventh. Now, our next rule is the power to a power rule. If I have x to the m, all to the n power, then I multiply these powers, x to the m times n. So quite simply, first example, if I had x to the third, all to the seventh, that would be x to the 21st. All right. But we also have to apply that power to everything that might be multiplied on the inside. Like if I had -2, a to the second, b to the fifth, squared. Well, that squared power has to go to the -2. Notice I'm putting it in parentheses, -2 squared. A to the power to a power I multiply, that's a to the fourth. Power to a power I multiply, that's b to the 10th. -2 squared is 4, a to the fourth, b to the 10th. All right. Now, just a couple other situations that I want to show you as general examples. You're going to be asked to simplify. All right. Like I said, sometimes they don't state the power. So on this first example, if I have 3p t to the third times p to the third t to the fourth, and they're both in parentheses, that's not a big deal. This p is p to the first. Well, you also need to know that I can multiply in any order. So I can make this 3 times p to the first times p to the third times t to the third times t to the fourth. Then I just add my exponents. This will become p to the fourth. This will become t to the seventh. The 3 just gets multiplied out in front. What if there would have been a 2 right here like this? Well, then the 2 and the 3 would have to be multiplied together, and it would become 6p to the fourth, t to the seventh. So just know you got to multiply these numbers out in front. All right. What if I have -2 x y to the third, excuse me for my bell, I'm going to keep teaching, like this. This power has to be applied to everything on the inside. This is -2 to the fifth, x to the fifth, y to the 15th. -2 to the fifth, that is not -10. That's bad. This is -2 times -2 times -2 times -2. You know what I mean? This is -2 to the fifth. All right. So this is -32. X to the fifth, y to the 15th. All right. One more problem. Let's say that I have 3xy to the fourth to the second, and in a bracket, I have negative 2y to the second all to the third. Well, look right here. I have a power to a power. That makes that negative 2y to the sixth. I have a power to a power here. Okay, it's this thing times this thing. So I'm going to clean this up first. This is 3 to the second. I've got to apply it to everything. X to the second, y to the eighth. All right. And so now I've got to apply the sixth power to both of these. This is negative 2 to the sixth, y to the sixth. This 3 squared is 9, x squared, y to the eighth, times this thing. Well, what is negative 2 to the sixth? It is negative 64. That needs to be multiplied by this 9. All right. And then I have just a plain old x squared by itself, so it stays the same. And then I have a y to the 8 plus 6, which is 14. And then I just multiplied these two. 9 times negative 64 is negative 576. X to the second, y to the 14th. And we will stop there for today. And I hope that helps you start getting an understanding of multiplying